So here we have the binomial theorem. Okay, so we start out with some binomial expansion. We have x plus y to the 0. We all know that's equal to 1. Anything to the 0 power is equal to 1. Say I have x plus y to the 1. We know that's just x plus y. Not interesting stuff. We've seen this many, many times. Okay, x plus y squared. If we multiply that out, we get x squared plus 2xy plus y squared. And that's our binomial theorem right there, our binomial for 2. There's for 2 because we know this is what we get, and we could put in any numbers for that. So that's binomial expansion right there. So if we said, how about x plus y to the 3rd? Now we're doing it 3 times, and what do we get? We get x cubed plus 3x squared y plus 3x y squared plus y cubed. Okay, so there's our for the 3rd. That's the 3rd expansion. And what if we had the 4th? What do we get there? We get x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. Okay, we should see some kind of pattern building right there, and that's what we're going to spend most of our time looking at these patterns. And let's do one more, and we have x to the 5th, xy to the 5th. So we get x5 plus 5xy4 plus 10x cubed y squared plus 10x squared y cubed plus 5xy4 plus finally y to the 5th. Okay? The exponents, we should start to realize what's happening with these exponents right here. Whatever power that is, these will always add up to that. So we have 2 right here, so we have 1 and 1 is 2. That's 2 right there. There's our 3. There's 2 here, 1 here, 1 here, 2 here. Always add up. The exponents will always add up to whatever we have here. So we have 4 on the outside. So we have 3 here, 1 here, 2 and 2 is 4, 1 here, 3 here is 4. The 5th we see it's 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, 5. So we see how the exponents work. And your other question is, well, how do I know what these coefficients are? Where are you getting these coefficients from in the binomial theorem? Where am I getting these coefficients from? I see how the exponents work, but where do I get those coefficients from? So that's a good question, and let's look at that. And before we look at the coefficients, we want to talk about our friend combination. And it's the C button on your calculator, but we'll show you where the formula is if you haven't seen it before. And mostly this happens under probability and statistics. This falls under. But it turns out that the C's, we could use the C's to help us find the coefficients of binomials. So before we do that, we should know our C formula. And the basic formula is n factorial over n minus r factorial times r factorial. Okay, so there is our factorial. So how does that work? That's a combination. It's more about count. It comes from counting principle, probability, and statistics. You see that more. That's probably where you studied it. If you did see it, say I have 8, 2. So we're going to do 8 factorial over 8 minus 2 factorial times 2 factorial. Okay? So let's expand that, and we'll see how this works. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8 times 2 is 6. So we're going to do 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 all times 2 factorial, which is just 2 times 1. Okay? Again, let's work smarter, not harder. What could I do here? I'm going to cancel out this right here with this right here. Okay? Leaving me 8 times 7, but I know that 2 goes into 8 4 times. So 4 times 7 means that this whole thing is just equal to good old 28.